stars are in the sky? Well, it kind of depends on what you're trying to see them with. If you are using a telescope, the answer could be in the billions. Before there were telescopes, people used to say things like, "Countless as the stars in the sky." Are the stars really countless? Decide for yourself. One approach is to use a statistical tool called sampling. Here's how. Instead of counting every single star in the sky, which is not very practical, we count all the stars in some fractional part of the sky and use the results to make a reasonable estimate. Let's start with a model so we can develop the concept. Suppose we have a chessboard with rice scattered on it. We want to know how much rice is on the whole chessboard. We select 5 squares at random. Our results come out as follows. Square 1, 7 rice grains. Square 2, 23 rice grains. Square 3, 11 rice grains. Square 4, 2 rice grains. Square 5, 15 rice grains. We can take an average by adding the total and dividing by 5. That gives us 58 divided by 5, or 11.6 grains per square. On the whole board, there are 64 squares, so our estimate of the number of grains on the board is 11.6 times 64, or 742.4. Simple, all done. Well, not so fast. Our estimate wouldn't give us such a precise number. There's no reason to suspect that there is a 0.4 piece of rice floating around on the board somewhere. In fact, in the number 742.4, the only really significant part is the 7 and the 4. So a more reasonable estimate is 740. Simple, all done. Wait, once again, we need to adjust our thinking slightly. Look at the original data. On square 2, we had 23 grains, which is very large compared to the rest of the data. On square 4, we had 2 rice grains, which is very small, once again, compared with the rest of the data. These might be what mathematicians call statistical outliers. Let's try rejecting them and just averaging the remaining 3 squares. We get 33 grains divided by 3, which is 11 grains. That's fairly close to our original value of 11.6. We have increased confidence in our original estimated value. Simple, all done. Hold everything. This was supposed to be about counting stars in the sky, not rice on a chessboard. Wouldn't it be wonderful if the sky were divided into little squares like a chessboard? Well, it isn't, so we have to create the squares ourselves. The sky is sometimes called the celestial sphere. We think of it as a sphere with us at the center. A planetarium is a half sphere. We imagine that the other half is below the floor. Let's divide the planetarium dome into 100 equal squares. Simple, all done. Wait, there's something wrong here. Squares aren't working. The squares aren't fitting. Let's try nice little equilateral triangles. That's much better! How many triangles are there? Now let's select 7 triangles at random and count the stars in each one, just as we did with the chessboard. In fact, let's follow the same procedure. Count the stars in each sample triangle and record your numbers. Find the average. Multiply by 40. Why 40? To find the answer, stop by the front desk and count the stars.